Welcome to the discussion with Chaos Group and the very latest in Figure 2 with Jimmy. We have a round of applause.
Thanks for coming. I'm Jimmy. I'm one of the more technical guys at Chaos Group. And today I want to tell you about V-Ray. We're showing you the Max and Maya. Before I do that, however, first I just want to let you know that in addition to V-Ray, we have some other products going on. We have a tool for simulating frames and things like that, water as well. And we also have a nice little sequence player that if you want to, you can come check out at our table over there. I'm not going to do that here. So I'm going to move on to the presentation, but I just want to get a feeling about the audience here. So how many of you use 3ds Max? Okay, and the others I guess use Maya. And how many use Maya? Okay, so much. Okay, mainly people from Max and Maya, and that's exactly what I thought it was going to be. So I'm going to show you the new features, but also I'm going to show you some of the other things and maybe show some ways that you didn't know you can use the feature in a certain way. So it has a little bit of a training element in there. Okay, I'm going to start with Maya and just open a very simple scene. And everything I show you, if I show it in Maya, you can be sure that it's there in Max as well. So everyone can use that. Okay. So what people usually do when they work is if you model your geometry, you tend to keep it in a low poly version, and then before you start rendering it, you'll subdivide it. The problem with this is that while you have it in low poly, it's cool, you can work in your viewport, but then you subdivide it and you end up with several million polygons, and then unless you have a quadro, you may get some troubles actually navigating in the scene. And the rendering also becomes very difficult because you need all the time to deal with this new geometry. So in V-Ray we have something called render time subdivisions, which in Maya is done like this. You can select any geometry, get to the shape node, and then if you go to attributes V-Ray, you can add these new subdivision attributes, which actually allow us to subdivide this mesh in render time. And you see now that as I render it, you get this subdivided mesh. Now, there's, as you can see, a couple of benefits here. First of all, you don't get this heavy geometry in the viewport, so you can keep working with low poly geometry. And the other thing is that V-Ray is actually very, very efficient memory-wise when it's creating this geometry. So in V-Ray we have something called dynamic memory, which is all this placement geometry, also division geometry, proxies, V-Ray for all these geometry types generated during rendering. And think about it is that it's only generated for those buckets that are currently being rendered. So you can see we're rendering these small squares. We only have the geometry inside them, so this makes it much more memory efficient. And as a tip to you, whenever you're rendering, as I said, for example, heavy displacement or heavy process, geometry process, which I'm going to talk about later, you want to optimize your memory. The way you do this is by going to the settings tab of the render settings and decreasing your bucket size. So if you have smaller bucket size, you keep less geometry inside and your memory will not end. Basically, you have more free memory. And you can also use this dynamic memory limit here to actually specify how much memory you want V-Ray to use. Now, something else I want to point out here, as you can see, we subdivided it, but we didn't have much control about how many times this was subdivided. So let me show you how you add the control. Once again, you pick the mesh, you go to attributes, and you add this subdivision and displacement quality. And here you have two options that allow you to control the amount of displacement. So basically, you set a maximum number of subdivision, and then with this max of this value here. So let me just put it to true and render. And you see that this mesh will be subdivided only 2 times. If I say it 1, it will be only 1 subdivision value. So you give it a maximum number of subdivisions, and then you specify a maximum edge length. So this new mesh that is going to be created, the length of the edge will be, in my case, over here it says 4, which means 4 pixels right now. And if you want to change it to world units, you can check this checkbox which says really dependent. You may want to check this whenever you have animations, because when you measure this in pixels, what happens is that faces that are close to you are subdivided more times than faces that are away from you. Because those will be far away and they still have 4 pixels due to the perspective of this model. Okay, and let me move this. So right now we again have this route geometry. As you know, in Maya you can do this smooth preview, where you just press 3 and things get smoothed out. So basically we export this and you can enable the rendering of the viewport subdivision from the global options here. We have this render viewport subdivisions, and if you check it, anytime anything you smooth out in the viewport will be smoothed during rendering. So it's a cool, nice way to preview your meshes. Okay, and the reason I got this one which is rough is because I had the displacement control over this one, so I didn't really have those. That's why it's a little bit rough. Okay, so this is something basic, but it's useful for basically memory efficiency. And let's move to something a little bit more interesting. I'm just going to open one thing here. It will take some time because it's actually one model that one of our artists created. It's around 10 million polygons and it takes some time to load. It actually has a lot of detail. So you see that my graphics card, which is a 480, GeForce 480 has some trouble rendering this out. And yeah, I should mention the configuration here because obviously I'm rendering and you'll be able to see the speed. This machine here is, for a lack of a better word, a laptop, but it's not really a simple laptop. It has 8 cores i7s on 3.3 GHz and it has 6 gigs of memory and a GeForce 480, so it's quite powerful, which makes me a happy person to use it. So you can see I have this heavy geometry. It's hard to work with it in the viewport. It's even harder to render. Fortunately, V-Ray was developed a long time ago when we had 32-bit machines. I don't know if you remember those. But there was a problem with being able to only use 1.8 gigs of memory and then you couldn't render anything. So back then, we developed a very useful tool that newer users just don't know about because they have 16 gigs of memory. But you can use it and speed up your renderings quite a lot. So what you can do is get this out geometry, and then if you go to create V-Ray, you can create process. So you export this geometry on the hard drive as a V-Ray mesh file. All the geometry is kept on the hard drive. You get in the viewport, you get a preview of this geometry, which I'm going to show you how it looks. And during render time, like with the subdivision geometry, V-Ray is only going through all the parts of the geometry which are currently being rendered. So this is what the proxy looks like. And if I click play, you see that we can actually export animation. So this proxy is animated, and we can also export the velocity information, so we can create motion work with this one. And right now, if I render it, you'll be able to see the speed at which I'm able to render this one. So this is the same, exactly the same geometry, 10 million polygons, but rendered as a proxy. And again, the same optimizations work. If we keep running out of memory, just make the buckets a little bit smaller, and you're set. Right now, you can see here it's getting slower because this is far away, and then it has to hold more memory, more geometry for this buckets. Okay, so it renders pretty quickly. Let me show you one scene that we created with this geometry, which maybe you'll be able to get inspiration where it came from. Okay, I have this particle emitter, which is actually driving around some process of the same one, and I'm not going to render this one because it's not fast enough for a presentation, but I'm just going to show the whole animation that we're able to create. And there's a reason for me to show this. We talked to some of the guys who made a similar shot in the Matrix. You probably remember this one with all the sentinels. And the feedback we got from them is that they had to use some sort of cloud computing, and it was very difficult for them to render this because they needed all the memory in the world to keep all their geometry. But with the proxy, we rendered this on one machine, just on a cloud plate service back home. So it's a pretty useful feature to have. Okay, another way you can use the proxy, I just want to show you. Here we have this model that was modeled in ZBrush, and once again we have around 10 million polygons. And you can render this inside Maya or inside Max immediately by just exporting this from ZBrush into OBJ file that you can see here. And then we have a tool that converts it to a V-Ray mesh file. So we convert this to a V-Ray mesh file, and I'm creating a scene. And I just have to go to create, V-Ray, import proxy, and find the mesh. I'm going to click create, and it will take a couple of seconds. And you'll be able to see how we render it. And also, something that's important about the proxy, because other softwares out there also have kind of proxies, but one big disadvantage there is that you just get the preview as a bounding box and you're not sure which is the front, which is the back, right? With V-Ray, when you're exporting the proxy, you can specify exactly how many faces you want to see in the preview, so you get an idea of the shape, and you'll be able to see the head of this guy sorted. It will look like a point cloud or something like that. Okay. There he is. So I can get an idea what's going on here, and let's take a look at his face. And switch to V-Ray, and I'm going to implement this optimization of the rendering, so decrease the bucket size and increase the dynamic memory. It's actually the same, exactly the same geometry, rendered quite quickly inside of mine. So this is another useful thing, and it also, as I told you, works in Max as well. Okay, so this is the proxy. Let's see something else. Inside here I have a very simple setup. I have this dragon. It has some sort of reflective material, and then this object here has the surface shader, which is basically the self-illuminated material, and the intensity I have set to 30 here. So what I'm trying to create here is basically have illumination from an object. And the way this works in all renderers is because this is not actually a direct light source, you need to have global illumination to get the illumination from this object. But the thing about it is that you have one very thin object here that's emitting the light, and then everything else is basically black. So the GI rays have a hard time hitting this thin object and then creating nice shadows from it. So you can see we get this blotchy result. And I can fix this, but I have to increase the settings so much that the rendering will be too slow, right? And also, there is practically no way of actually creating photon map caustics here. So let's see how V-Ray can help here. I'm just going to pick this object, go to create, V-Ray, and then V-Ray mesh light. We have this turn selection into lights. So what this will do is it will add new nodes to my geometry, and this node will have all the controls of a standard V-Ray light. You have those in Maya, you have them in Max as well. And now I'm just going to render. And you'll be able to see that it will create a much better result, much faster. And you'll also get the caustics here. So I'm just going to turn off this a little bit. So I'm not sure how much you see, but there are some caustics over there. And this will speed up your this kind of setup quite a bit, and you can also really make it strange if you just, for example, add a texture here. So let's say around. And this scenario is like hell to render with only GI. You will get splotches, you'll never get nice shadows, and you can see you get pretty nice shadows here, even at that speed. So obviously I'm using a little bit of lower settings so I can get the rendering faster for this presentation, but still the quality is quite good. Okay, something else about lighting, and I think this is going to be the last in mine. I can switch to Max. One of the things people often do is use an HDR image to illuminate the scene. So what you'll do is have the HDR in the environment, and then use global illumination to get the light from it. But the problem with this one is you get basically the same problems you get with object-based illumination. The thing is that you have this HDR, and it has some parts that are very, very bright, and then some other parts are very dark. And in the samples of the GI, I get a lot of variation, which in the end creates splotches and nasty results. I'm going to render, and you'll be able to see what I'm talking about. And this is actually not a problem of V-Ray, it's just the way this approach works. What you need to do is actually have very high quality global illumination, like with many, many samples, so that you can hope you to get some sort of evenness in the final GI solution because of all this variation in color. And what usually happens is you get splotches like this, and the contact shadows are not present at all. So this object here should have some shadows, and right now it looks like it's floating. You also don't get any shadows here. So V-Ray can help you there as well. So let's see how we do that. We have this, if you go to create lights, we have V-Ray dome light, which is basically our way of creating image-based lighting. You just put it in the scene, enable it, and then for the dome texture, you specify the same file, this one. And I'm just going to render straight away. Now, what happens is V-Ray will know that you want to use this texture for the illumination. It will actually examine the texture, it will find the bright spots, it will find the dark spots, and then it will shoot direct light from the bright spots, which is very different from indirect light. It's much easier to trace. It creates nice shadows, as you can see here. Right away we get this nice contact shadow, which you can never create with only GI. And it basically creates much better result, much faster. And you can see we have these contact shadows. Now, right now this rendering is slower than the previous one, but this is because we're tracing a lot of direct light. And if I wanted to create this quality with GI, it will be way, way, way slower. So it's actually an improvement in speed right now. And while this is rendering, I'm just going to show you what we were able to render with this approach on our one of our machines back home. So let's adjust the color space. And so you can see this image, this material actually is a sort of a marble. It has some subsurface scattering, and you can see the amount of detail in the lighting that we can get. We don't have depth of field. This was rendered anyway. I'm not entirely sure if it was 1 hour or 2 hours, but it's only on one machine, and the clock is actually a V-Ray proxy, so we're combining things together. So let's see, this is almost ready. We created this image on my machine for 1 minute 23 seconds. So it's a real nice optimization, especially if you're dealing with image-based lighting. And I'm pretty much done with mine, so I'm going to switch to Max right now. And I'm going to start basically with the new things that we have in 2.0. So one of the new features we added in V-Ray 2.0 is actually that we have introduced the V-Ray RT as a part of V-Ray. So let's take a look at it. Basically, V-Ray RT is a separate rendering engine which uses progressive path tracing to create the image, and it creates the image at a lower quality first and then constantly improves the image. And it allows us to actually be able to render things much quicker and see the effect of whatever we're doing much quicker. So we want to use this whenever we're working on shading, on lighting, because you can see that we get the instant feedback. I need to switch to max navigation now. And you see that it basically refreshes very fast, and especially for creating things like materials, it's pretty useful. So one of the most common things that people ask me when I go on this kind of things is that how do you create layered materials, how do you create, for example, a car paint shader? And I'm just going to very quickly show you how easy it is to do this with V-Ray and how much easier it is with DRT. So basically, the car paint material, if we examine it, we have two different layers. We have one base material, which is the metallic paint. On top of it, we have the coat material, the coat layer, and then we need to combine those somehow. So first of all, I'm going to set up the metallic paint. So let's zoom in here. And in the meantime, you can just examine the performance of V-Ray RT. So it's 2-in-1. Okay, so metallic paints, they don't have any diffuse, so I'm just going to make the diffuse black. And actually the color is coming from the color of the reflection, so let's pick some color here, something darker. And the color of reflections are actually the color of my car, but I really need to make those a little bit blurry, so I'm going to decrease the glossiness to, let's say, 0.8. And you can see the result immediately. And V-Ray RT shines in situations like this when you have a lot of glossy stuff, or a lot of blurry materials, blurry reflections, blurry refractions. That's when it calculates those things much faster. Okay, so Yeah, let's make this material a little bit more interesting, because just a simple cover is not that much fun. I'm just going to, instead of cover for reflections, I'm going to use a flow of texture and pick some colors. It's going to be red, the other one is going to be orange. And you can see we get this material that kind of is a little bit red here and yellow there. And let's just switch to Fresnel here, so it will blend them a little bit differently. Okay. Let's assume that this is one of those chameleon materials, not exactly, but kind of, it has an interesting effect to it. And it looks pretty nice. So right now on top of this one we can actually put the cold material, and first of all we have to create it. So I'm going to get a new V-Ray material, drag it in here, and the cold material is very easy to set up. It's just almost completely reflective material. So we don't have any diffuse, we had a lot of reflections, and with V-Ray it's never a good idea to use perfectly white color for anything, because it kind of screws up the energy preservation stuff, just a pointer there. And I like to put just a little bit of blurriness here, so 0.98, just to get some speculars there. And this is my cold material. Now I'm going to blend those two using the V-Ray blend material. And if you're creating those kind of shaders, always use the V-Ray blend material. Don't use the max blend or the Maya layer shader, because the V-Ray blend material is much better optimized for, especially if you're blending like 10 materials. If you're using the max standard one, you have to calculate GI, reflections, everything for each material separately and then combine them. If you're using the V-Ray blend material, V-Ray kind of compiles one material and then you can pass away with only one calculation. Okay, so let's select my blend material, and I'll put the base for base material, and I'll put the cold for cold material, and let's assign this to my next one. Yeah. So I'll assign the blend material to the car, and you'll be able to see the result. And right now, I can use this cover here to basically control how much of each material I see. So I can make it look a little bit better. But of course, if you want to make it more realistic, once again, it's a good idea to use the fall-off and just use the Fresnel type of reflections. It makes it look pretty cool. And let's zoom in on it a bit. The thing about the art is that, as you can see, it's poor quality right now, but in a couple of seconds it will be much better. So for example, let's say you're newbie to V-Ray, you don't know what settings exactly you want to use to create a good quality image. You can start RT, leave it for as long as you have, and you can be sure that for the amount of time that you have, this will be the best rendering that you're capable of. So if you know what you're doing, you can set up, for example, the GI solutions better, and you can get faster render times. But if you're not very proficient with it, this will make it much easier for you to create this kind of images, because it's constantly improving it. Okay, so this was the hard way of creating the car paint material. Basically, in 2.0, we introduced this new type of material, which is called V-Ray car paint. And it does all of these things for you, so you don't have to blend anything together. You get the two basic layers. We have the basic layer and the coat layer, which are pretty straightforward. I'm just going to show you that you can change the color here of the base material, and you can increase the strength of the coat. The interesting thing here is not those two layers. So if I increase the coat, you'll be able to see much more reflections. This is pretty straightforward. The interesting thing here is that in between those two layers, we have a third layer called flakes layer, which allows us to add those metallic flakes that you see here. Now, the reason we see them so big right now is because actually we don't have any UVWs, and we're using the wrong mapping type. So I'm just going to switch to triplanar mapping. And I'm going to very quickly explain how those work. So right now they're very, very small. So I'm going to increase their size. And right now, okay. So there's a whole bunch of them. I can also control the density with this density parameter. So if I set it to 0, I will basically remove all the flakes. And if I increase this too much, I will only be able to see flakes, which is not a good idea, as you'll see now, because it's going to be very, very noisy. Okay, The cool thing about this flex layer is that there is no other way to actually create it. So V-Ray is blending several textures, and all these flex, all of them are reflective, but some of them reflect from one angle, some of them reflect from another angle, so it really adds realism, and it's very easy to set up. So you have the density, and then you have size to control the size of the flex, and the scale to control the scale of the whole shader. So if you increase the scale, you're increasing the size of the scale of the flex, and also the distance between them. So if you're moving from scene to scene, you can just change the scale. Okay, and it's also capable of producing some pretty nice results. Okay, I'm going to speed up a little bit because I don't think I'll have enough time for everything. Okay, some of you, I'm guessing most of the Max users have at least once dealt with interior scenes. And as you know, V-Ray has this very nice solution for rendering the GI in interior scenes called the light cache. But sometimes the light cache produces issues which, like this one, as you can see here, we have some color light leaking. Now, this scene was intentionally set to create these light leaks. What's happening is that we have this very thin wall, and then behind it we have the light source. And the samples on one side of the wall are very bright, the samples on the other side are dark, and because the size is too big, the light is practically leaking out. Now, you can fix this at any point, but again, it will require that you have a better understanding about what's going on here. And in 2.0, you can very easily fix this by just checking this checkbox here, retrace threshold, which will make V-Ray detect those problems where they're happening, and then you're setting up a radius which is wherever there's a problem, in my case 10, so 10 pixels around this problem, V-Ray is going to switch off the light cache and use my primary engine, which is in this case the redness map. So right now when I render, it will fix all those issues automatically. And the other thing that I forgot to mention is this glossy reflective thing here. This, actually, we're using the light cache for glossy rays, so we also fix some of the splotches here as well. And the cool thing is that it doesn't require too much understanding. You just check the box and you're done. Okay. Next on the list, if we have time, I'm going to show you some. I have more interesting ones right now. Okay, I have this scene. It's a very simple setup. Basically, I'm displacing this plane, but you'll see that as I move this thing here, the pill, it's actually changing the displacement based on the distance between the two objects. So, do you have any idea how you do that? Yes, you do. Okay, don't tell you. Basically, you have textures which can, for example, the V-Ray dirt texture gives you black color where objects are close together and white color where they're far away, and you can switch them, it doesn't matter. But the thing about this one is that it actually requires ray tracing to create it, so you cannot use it, for example, to create displacement or to control dynamic geometry as a whole, V-Ray for the length of something like this. Well, in V-Ray 2.0 we introduced a new kind of texture which is called V-Ray distance texture, and it gives you pretty much the same result, but the only difference is that the texture is calculated before the actual rendering takes place. So this allows you to create things like, as I told you, displacement, and you can control the length of the V-Ray fur. So this is what the distance texture looks like. You have far color, near color, and inside color, which is the color inside the object. And the only thing is that you have to specify which object you want the distance to be measured to. So you just click add and, for example, pick this one, and then this texture will give different colors based on how close it is to this object. So this allows us to do things like that. You'll see this on this object. I have the V-Ray fur, and I'm actually controlling the length of the fur with the help of this texture. You can see that as I move this, the fur grows around it. So just an example where you can actually use this. So let's say you're making an interior scene and you have an animation with a character walking on a carpet, and you want the feet to deform the carpet. This will be very useful because otherwise you'd have to create manually texture for the displacement. So this is one example. I guess also you can sort of probably make an object leave dents in snow or whatever. If you want to simulate something that's soft and something else is deforming it, that's a nice way to use this texture. And we have a lot of geometry here. You can see in the realism map that we actually added for here. I can show you the final image because we don't have that much time. Here's the actual rendering. Okay. Moving on. Here's one really amazing scene. How many of you have sometimes had to deal with like camera matching, things like that? Basically you know that one of the hardest things to do is to match the distortion, because every camera has its own unique distortion, and it's pretty hard to do that, because you actually need to use a mathematical formula that's hard to get the same distortion. And if the distortion of the real camera, the footage that was taken with the real camera, and the distortion in your CG footage don't match, you don't get a nice image at the end. Things get messy. So in Viri 2.0, we added a small tool called Viri Lens Analysis Tool, or utility. Here it is. You can find it in the tool in the installation. And it actually allows you to download the distortion profile of whatever camera you have in your hand. So what happens? I'm going to very quickly show you how it works. So you need to go to analysis, run the tool, go to analysis, and then select print dash chart. It's going to ask you about the aspect ratio of your camera. You pick the camera, the aspect ratio of your camera, and then you will print something that looks like this one. So you place this on the wall. You have to light it properly. In our help file, there's a very detailed information about the lighting and how exactly you should take the pictures. Then you take several pictures with your camera, and then those pictures will look something like this one. And you also, if your camera, for example, has a changing focal length, you'll take, for example, 2 pictures for the most zoomed in, then 2 pictures for the most zoomed out, and then somewhere in the middle. So Viri has information enough to interpolate between those values. You take these pictures and then you feed them to the tool. And then you click Analyze. Viri will do it's not Viri, it's the small tool will do some analysis. And then you get this information. So you can see it can actually read the metadata. So it knows the focal length and the other information, it understands it. So once you have this, you just click Consolidate Profile, and then you can save your profile with something with a creative name on your desktop. And then you get this file. You have to use the Viri physical camera, obviously. You select your camera, scroll down to the distortion type, and you see that we have a new type of distortion, which is called lens file. So what you're going to do is just load this lens file that I just created. And when you render, you'll be able to see the distortion. So it will make it much easier to match things, and you can also use this tool, distortion profile inside the tool in order to correct or distort images with the same distortion of your camera. So you can do that with sequences or anything like this if you don't want them to be distorted. Okay. Next on the list, we have a very interesting texture. So in here, all the grapes in this scene have exactly the same material. All both pairs have exactly the same material. But you will see now, it will be most visible in the white case, that obviously they look different. The 2 pairs, this one is green, this one is brown, and it's quite visible that these are actually different colors. And we'll give it a second so we can render out, so we can see that even between all the green grapes, they actually have some small variation. So if I want to do this with an older version of Viri, so this is a little bit lighter than this one, I would have to create materials for this one, materials for this one. For each of the different variations, I need to have different material. And what I can do instead is use this new kind of texture, which is called Viri Multisub. And it's pretty much like the multisub material. It actually allows me, I'm going to assign this texture to one of the slots in a material, and then based on the material IDs of the faces on which this material is applied, it will give different values. And this was a mouthful, so let me just show you. So this is the material for my grape. It's a very complex material, but basically we have the base material, which is this subsurface shader, And this subsurface shader is getting the color from this multi-subtexture. If you take a look at the settings of the multi-subtextures, you'll see that for IDs 1 we have this color, for ID 2 we have this one, and so on. We have basically 12 different variations. So if I go back to my scene and select some of this geometry, you will, this one has ID of 8, these ones have ID of 5, and that's how I'm adding the variation. And the same thing is true for the pairs, but instead of using this kind of IDs, face IDs, I'm actually using object IDs. So object properties, this one has an ID of 2, and the other one has an ID of 1. And the shader looks pretty much the same with a small difference. So if you take a look at the shader, you'll see that this time exactly the same setup, the same texture, but instead of feeding direct colors, we're feeding different textures. So this is the texture from one of the pairs, and this is the other one. And also, we switched this get ID from to object ID, so it was face IDs in the case with the grapes. Okay. Okay. I'm just going to show the scene because I have like 5 more minutes. So in this scene, very straightforward setup, many lights, and we added a new render element which actually allows me to extract the contribution of each light, extract it in a separate render element, so I can later combine those together and get the final image. This is done through this light select render element, so you just add it here, and you click up, pick the lights you want to, and they will get inside this list. So you can have one light on each render element, or you can have 5 as many lights on a single render element. And let's render. So the thing about it is that you can actually, when you use compositing in the end and combine all of those render elements, you can apply small color corrections, change the exposure, for example, of one of the layers, and then change the color illumination in the scene, which is pretty useful, especially if you, for example, if you had rendered the whole animation, then the client says, okay, I want this light to be a little bit stronger, you have to render it all over again. But if you render with render elements, you can make minor changes. Of course, if you just increase the intensity like 5 times, it will be obvious that something's wrong, because the GI is not going to be immediately affected, but still you can get a real nice effect. And I'm just going to show this, stop it, and move it to PD player, which I'm going to use for the compositing. Okay, so this is the beauty pass on the side, and I'm going to just add the other layers. So this render element is called all lights, is for this one on the side. So let's say I want to change the exposure. You can see that it's affecting the entire scene, and I can also play with for example, the saturation, so I can change the color, which is it will be most useful in animations, because it will make it easier for you to adjust things a little bit later, do some minor changes. And now we're going to my favorite feature of all. Okay, I have a couple of things here. So this one is pretty simple. I have 2 plane objects, and they both are displayed with some noise. The top one is transparent, it actually is refractive, and I'm creating caustics. And the bottom one is also displayed, and it has this texture of stones. What I'm trying to create is an animation where the waves of a pond are moving, and they're casting those nice caustics here. And you can see it looks pretty nice, but it doesn't feel too real, because basically you've seen this kind of things too many times, and you kind of know that there should be some color inside these caustics, because when light passes through refractive objects, it's basically dispersed, right? So in 2.0 we had this the ability to create dispersion into the standard V-Ray material. So this is the material for the water, and if you go to the refraction part, you'll see that we have a new checkbox which says dispersion. So I'm just going to enable it, and you'll be able to see the difference right away. It's just a simple checkbox, but it will help you a lot if you have scenes with many refractive objects, for example, some chandeliers or some crystal glasses, whatever, where you have refractive materials. It will add a lot to the realism of the scene, of the final feel of the scene. And you see that we get small colors here. it's very faint, but I'm going to show you a better example in a second. Here's what the rendering will look like. Now, having this feature, and like if you have a little bit of time and you're a fan of a certain band, you can create real nice things like this one. The moment I got this feature on my hands, I just had to create this scene. So it's a very simple setup. I have this animated light on the side. It's a direct light. This object is transparent. It has the dispersion enabled. And the interesting thing is that I have this environment fog. And I'm creating caustics. So I want to create volumetric caustics, basically. And I have the V-Ray tool because I want to be able to see the edges of this pyramid there. So let's pick a nice angle and render. And hopefully you'll be able to recognize where the inspiration came from. So there you have it. It's nice. It's actually wavelength dispersion and creates pretty nice result and also makes them pretty quickly. So if I pick another camera and hit render, and while I'm rendering, I'm just going to show the animation. You can see that you can actually, it's not only for realistic things, you can make also some fake stuff that looks pretty nice as well. And it's rendered pretty quickly as well, as you can see. Because we have, this is actually very hard to render. We have volumetric caustics and dispersion. All this stuff is not very easy to render, but you can see the result. Okay, so I'm just going to end, I already run out of time. I'm going to end with a simple comparison. I have this very complex scene, but it's very hard to render with the RT basically. That's the reason I'm showing you this one. It's an interior scene. These tiles, all of them have some little bit of blurry reflections, and basically this is very hard to render because you have to trace a lot of rays, a lot of GI in order to get the illumination, and the illumination is actually coming from 9 IS lights. So now I'm going to use the CPU first to render, and we actually have this show statistics checkbox allows me to see some numbers here, which tell me the speed, the current speed at which the RT is rendering. So it will take some time to load the scene, and you can see that it's really refreshing not that quickly, it's refreshing quite slowly actually. And right here we have 20 point something K paths per second, which means that we are tracing 20,000 rays each second. This is on 8 i7 cores, it's on 3.3 gigahertz, so it's pretty, I have some render power here. So this is the speed. And I want to just very quickly compare it with running the same thing on the GPUs. This is 480, GeForce 480, some mobile version of it. Okay, you can, even without these numbers here, you can see that this one is much faster. And let's take a look at the numbers to take a second to refresh them. Okay, here we go. So now we have 424,000 paths per second. So it's almost 20 times faster in this particular case. Now, the bigger difference will be seen when you have a more complex things to calculate. Because you know, the thing about the GPU is that you run those parallel processes, and the more complex the scene is, the more V-Ray when running on GPU will be faster. And it will vary from scene to scene. But this is just one simple example of the speed difference. And just to give you the pros and cons of RT on GPU, you get it anyway, so you can use it if you want to. But when choosing hardware, if you decide to use this one, keep in mind that right now RT on GPU is running using OpenCL, which is quite new, and it's still underdeveloped. So the V-Ray RT on GPU doesn't support all of the shaders, so it has those kind of limitations. You can check check our website, all those are explained. And the other main disadvantage is the fact that graphics cards, they don't have much RAM, right? This one has 1.5 gigs. The more expensive ones, like Tesla's, they have like 6 gigs, but still, if you compare it to the, for example, our blades, I think have like 32 gigabytes of memory. The difference is quite big, and the problem here is that you cannot be memory efficient using the RT, because the RT, being a progressive path tracer, it renders the whole scene in the same time, so you need all the geometry, all the textures inside. So right now still, I would say the VRAM CPU is better because of the hardware, but we hope that as the graphics card get better and have more memory and better support for writing on code for them, it will be the RT1 will rise. Okay, so if you have any questions, you can ask me now. You can also, I think we'll be here until 6. Our table is back there to your left, maybe right from the entrance. And I'll be glad to answer those. So if you have any questions now, because if I answer them now, more people will get them. It will be more useful. No? Okay, well, think about it. I'm still here, and thanks for your time.